All right. So what we have here at Central Region, we started collecting data as early as, I think it was March of 2011, and we began collecting all sorts of text products and databasing them. And the ones of most interest were warning products. So we started collecting all the tornado, severe thunderstorm, flash flood warnings, and all the follow-up products. In addition, as IBW came on, we started databasing all the tags associated with the IBW. And one thing I will caution you as I show some of my slides, the key thing to remember is IBW didn't start till 2014 and really wasn't widespread across the country until 2016. So the record I have for some of the IBW stuff is pretty short, so we can't draw a ton of conclusions, but it's still pretty interesting to look at. The first slide I have up is what we did is we took every single tornado warning that we had in our database, all the news, so not the follow-ups, just the news, and we gridded them to a 1 kilometer grid. So we used the Landscan ambient population data set as a background reference grid, and we essentially had a program that took each tornado warning, converted it to that 1 kilometer grid, and then essentially just stacked all those up. So each place there was a tornado warning was a 1, and every place else on the grid was a 0, and then we just summed up that entire grid. And what that gave us was a grid point count for total number of tornado warnings. So the first thing everyone notices, there's definitely some dry areas on the map, such as Western Michigan, where you kind of have the impact of the cooler water of the Great Lakes. You can see some impacts from the Appalachians and clearly impacts over or decreased tornado warnings over the Rockies. But what's more interesting is you see a lot of hotspots on the map too. And so we started looking at those hotspots, and it's pretty wild because you see that we've had, maybe 40 or so tornado warnings issued across parts of southern Alabama, southern Mississippi, and down around Lake Pontchartrain. So that's kind of interesting. So we thought, okay, what's up with that? Is it just, is it a WFO warning philosophy, or is it something else? Well, of course, it turned out to be something else. So during that time period, we had 4 major tropical systems impact those areas. So we had Irma that went up the west coast of Florida and produced some localized tornado warning maximums along the east coast of Florida. We had Harvey that came ashore in Texas that produced the local maximums both in southeast Texas and a little bit in western Louisiana. And then for that area from New Orleans up just north of Mobile, we had both Lee and Isaac. And what's interesting is one point northeast of New Orleans had 7 tornado warnings from Isaac and 5 tornado warnings from Lee. The other interesting point is sometimes you just drop a lot of tornado warnings in a day. During an outbreak in April 15th of 2011, Mobile had a tornado warning out for the same grid point 9 times over the course of a day, and it was spread out over multiple hours, so it wasn't like the same warning just being reissued. It was multiple warnings issued for a single grid point. So kind of interesting to look at. The next thing we thought is, well, let's take a look a little bit at tornadoes. So what this is up on the screen is a snapshot of the SPC Tornado Database. And what we did is we downloaded the database, and associated with that is a start and stop lat long for each tornado and a width. So we changed the line segments into polygons, and as you can see, there's thicker ones and thinner ones based on the width. So we assumed the average width across it and created a polygon data set. So the next thing we did with that is we went ahead and assigned it to the 1 kilometer ambient population grid set. And what's kind of interesting on this is that there's a few grid points that have seen 4 tornadoes in less than 8 years, which is crazy. I don't think I'd ever want to live in that area if I'm going to have 8 tornadoes go within, or sorry, 4 tornadoes within 8 years in a single 1 kilometer grid point. That's just crazy. So then the next step is we took that data set and matched it with the tornado warning. So we examined every single tornado warning, and if that track intersected the tornado warning during the time the warning was valid, we threw it out. And so the map I have up now is essentially, we've removed all the valid, or all the verified warnings, and this would be essentially all the false alarms. So you still see the hot spots, but it's kind of interesting. Like I said, you can definitely see some areas where there's a lot higher tornado warnings. Some you expect, like out northeast Colorado, where they have a lot of landspout activity, and then of course we see the tropical activity down in Louisiana and southern Alabama. Shifting gears a little bit, I know a hot topic with the Twitter warning graphics is everybody's always looking for the zero population warning. So we were kind of curious, how many warnings do we have in our data set that have 0 people? So once again, this is the tornado warning data set, and it goes back to about 2011. And we had only 5 warnings that had, or 32 warnings that had 0 population in it. And so up on the screen, the red is the ones with 0 population. The ones are in yellow are with only 5 people in it. And as expected, a lot of the 0 population ones are very small warnings, and most of them are concentrated across the plains where there's less population density. It is interesting, though, that we had 2 down in the Everglades. And then kind of taking that a step further, we looked at all the events that were tagged with the catastrophic and with the considerable tags, and looked at the population associated with those events. And once again, I got to throw out the qualifier that the data set, for this really didn't start until 14, and east of the Mississippi, it's really only valid since 16. So, insert all the appropriate caveats there. But we had 16 events where we had a considerable tag, and the population was less than 1,000. And one of those events only had a population of 83 people. The least populated catastrophic tag was about 6,200 people. So then we kind of took a look at the hail and wind tags. So what I have up on the screen here is these are all the warnings that were issued since we started collecting the hail tags that had baseball-sized hail or greater during the entire duration of the warning. So we looked at not only the initial issuance of the warning, but the SVS, and kind of treated it as that one event. And if any time during the lifespan the hail tag was baseball size or larger, we went ahead and plotted it. And then we plotted it with a light opacity. So as you stack them up, the brighter colors mean higher density of those warnings. It's not surprising that you see the highest concentration of events in the high plains. There's currently talk potentially of having a new class of severe thunderstorm warning, and one of the categories for that was potentially baseball-sized hail. What's interesting is we've had 1,400 events, so if that were the criteria, we'd be issuing a lot of these warnings in any given year. Then we stepped it up a notch and just said, okay, well, what about 4-inch events? And as you can see, 4-inch events are pretty rare. Once again, qualifiers with the length of my data set, and pretty much restricted to the plain. So if we were to use a 4-inch qualifier, we're looking at about 122 warned events for that time period. So next we took a look at wind tags, and this would be any event with tags of 70 miles an hour or greater. And once again, you can see a lot of events. We have nearly 12,000 events, and pretty heavy coverage over most of the country, short of South Florida and west of the Continental Divide. But what gets really interesting is if we change that tag to 75 miles an hour, it cuts it by nearly an order of magnitude, and we only had a little over 1,300 events. What's even more interesting is if you start looking at the spatial representation of these, you see some pretty interesting artifacts start showing up. There's some pretty clear discrepancies as you cross from one CWA into another. That could be for any number of reasons. It could be a warning philosophy. It could be the tags that are available in WarnGen for forecasters to pick the wind speed. But it is pretty interesting to see there's some pretty heavy CWA artifacts in that data. And then finally, if we were to step up to 90-mile-an-hour winds, you can see those are pretty rare, and we only had 97 events in our database. So, and most of those, once again, were pretty much in the central and northern plains. So kind of to wrap things up, the majority of some of our observations that we noticed playing around with the data set, the majority of the baseball-sized hail tends to be located in the plains, although we have to caveat that, of course, with the limited data set. Hurricane tracks can heavily influence tornado warning density. Like I said, you know, when you get that point in New Orleans that had 10 or 12 warnings from 2 tropical systems in the matter of 8 years or 9 years, that pretty much blows your statistics for a number of years. And then finally, as you could see when we took the tornado tracks and gridded them and compared them to the warning tracks, there's definitely an over-warning given the size of the polygon, but also that tends to be offset by, we typically have other hazards associated with that, hail and high winds that occur well outside that tornado track. But it is interesting to look at the comparison between the two. So that pretty much wraps up the material I have, so I'm open if there's any questions.